Hey, Natasha.
Hey, Claire.
So we've left our listeners in suspense because there was a
I'm
big
sure.
cliffhanger at the last one and I really want to know about this class you're teaching. So back up. What class are you teaching and why?
I am attempting to get a PhD in curriculum and instruction, and apparently they have decided I'm qualified to teach an undergrad class because I just got my master's in science education. And so part of this degree is like, you have to teach a class. And it was terrifying because if you know anything about like 18, 19, 20-year olds,
Nope.
yeah, me neither. I don't either. That's why it was terrifying. Um, and just the having been through college like many, many years ago, and we're always like judging professors, right? Like, oh my gosh,
Yes.
or like, oh, here's a really good one. And you're like, you just, as an educator, like everyone listening, you want to be the one that they like. You want them to like want to come to class,
Hmm.
but then you also have to teach them something. And so it's this very difficult balance. And never having taught undergraduates, I wasn't sure where the balance was. What do they already know? I don't have, I know the content, but I don't what we call in grad school terms pedagogical content knowledge. PCK, as my professor says. She's like, you don't have it. So you're just going to go in blind and you're
Hmm.
going to try it. And the next day you're going to be like, well, that didn't work. Let me try something else. Um, okay, so I have two other grad students who are teaching the same class but different sections.
Hmm.
One has an undergrad in physics, and one has an undergrad in engineering science. And they have very different approaches. So the class is Inquiries to Physical Science. I'm teaching elementary educators. They're mostly pre-K through 8 wanting, or they have to take this class. That's the problem. They have to take it. And they have to learn about physics and chemistry and to be able to pass their content exam, but also to teach it to their like third graders or fourth graders.
Hmm.
So the physics major, she takes a very idealized approach of like, we're going to learn all these like fancy things like inertia and like the physics side. And she's like very passionate about. And she wants it to be like very, oh wow, science, like that is like kind of the vibe,
Hmm.
if that makes sense.
Yeah. Blow
You
your
know,
mind with science.
exactly,
Okay.
yeah, come walk away like all these like mind bending whoa moments. And then the other side, she takes more of the engineering approach, which is how does this relate to my life? Like what's something I do every day that I can now explain with some
Hmm.
science or that I can apply to science? Which approach do you think I am taking?
The engineer approach.
How did you know? So, yes. And I was told by my husband that he was like, you will spend too much time on this class. So you just need to do what she's doing. Just take her lessons, take her content, and just go with it. And you can like modify it, make it your own style, but it's just going to be a lot of work to try to do your own thing.
Hmm.
Do you think I listened?
No, how can you do that?
I
That would be the
know.
easy way,
That
Natasha.
would
You don't
be
know how to
the
do that.
don't.
And the
So
boring way,
the
okay?
boring way, right? I run Space Club, right? I started that a
Mhm.
while back and I've been doing Space Club. And I was like, it would be kind of fun to do a space themed version of this class. And
Yes.
right. And Justin's like, no, 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 do not do that. I was like, okay, fine. So this was like my initial idea, but I was told to kind of back off from it. And he was like, just teach the class once and then do it your way. And I was like, that seems very like good advice, right? Practical advice. So I walk in and I'm doing the lessons exactly as I have the other instructors are telling me. But I bring in this video of my students from Space Club, and they're showing off like their Mars colony projects, right? And then I talk about the fact that I'm an aerospace engineer, and I don't think anything of it, so we like move on. And my students were like, "Wait, what? Wait, okay, so what were they doing?" And they start asking me all these questions about this colony project. And so then the next day in class, as a warm up, I was like, "Ask me anything about space, like write it on the board. Like, what are you interested?" And they would not stop asking me questions. One girl's like, where do your tears go if there's no gravity? Like, they were, like, good questions.
Interesting.
And
Mhm.
then it was, like, silly stuff, like, how do you go to the bathroom? Like, everybody wants to
Everybody
know,
wants to know, yeah.
right?
Mhm.
And then one was like, okay, so, like, what is up and down? Like, these really good,
Ooh.
deeper questions. And then I started realizing that they don't think there's gravity on other planets. Like, they think only Earth has gravity because everything we've seen in space are floating. So there must
Mm.
not be gravity on the moon or Mars. Like, these really wild misconceptions. And so now every start of class, we start with a space video. And I show them, like, trying to prove that there's gravity on the moon. Or we had this cool video of, like, this water experiment where they put an Alka-Seltzer tablet in, like, a
Mm.
drop of water, and, like, just weird stuff that happens in space. Or I did the Space Lander video, the 7 minutes of terror, and the rovers, like, dropping down, and all this crazy stuff. And they're like, "What? We have rovers on Mars?" 1, they don't know
What?
there's rovers on Mars. 2,
What?
they don't know there's an International Space Station, never heard of it. They had no idea that people live and work in space.
Uh, w wait,
I
how?
know. Isn't that sad?
That is so sad.
So let's just say this has turned into a space class.
I was about to say,
I can't help it.
at the
Like,
beginning of you describing your husband's, advice to you, I was imagining, like, how the cartoons that have, like, the devil and the angel on your 2 shoulders that are giving you advice? So I was trying to figure out which one he was and which one I was, but now I know.
what do
I'm
you
the
know?
I'm the angel, and I would
You're
have
the
told
angel.
you to do space.
There you go. He's the bad guy. Well, I tell him it wasn't my fault. It is my students' fault because they won't stop asking me questions about space. And I show, like, the video of this water droplet. And one student wanted to know, how do we take a bath in space? Like, how do we wash our hair
Hmm,
if, like, the water is doing all this, like, weird stuff, right?
great
And so I show the
question.
video, and this kid was like, that's not real. That can't be real. Like, they were just blown away by this simple video that I would play just randomly, like, to my space club kids. And this has just, like, reignited my passion for space education, because these students, let's just say when they first walked in, I do the mystery box. And this is related to the last podcast because you were
Mhm.
like, ask good questions. So I was like, here's a box, and I want you to figure out what's in this box with yes or no questions only. So the first student, this was my icebreaker. Like, tell me your name. What do you want to teach? Ask me a question. They're like, okay. I don't know. Is it yellow? Like, they're not even trying. And so I start getting more into it, right? But, like, okay, whatever. It was like fine activity. And I do recommend it, like, especially for younger kids. They would probably be more excited
Mhm.
about it. But then I reveal what's in the box, and it is, did I tell you what was in the box? Any guesses?
No, no, I
What
don't.
do
What
what
can I guess?
Yeah, you guess. Okay.
Is it related to space?
Yes.
Is it, uh, a figurine?
Yes.
Okay. Is it
Kind of.
something that I wanna be when I grow up?
No.
It's not an astronaut.
No.
No. Is it something from NASA?
Yes-ish.
Okay. Is it something you wear?
No.
Is it something that's a toy?
Mm. It
Is it
could be.
is it intended for entertainment?
No.
Is it intended for decoration?
Yeah.
Okay, now I wanna know. What is it?
I have it over there. It's a bright pink 3D model of a rover
Oh, that one of your kids 3D printed?
that one of my Space Club students 3D printed.
Okay.
So, pretty good. That you did pretty good. And so they actually almost got it because someone guessed, "Is it a car toy?" And I was like, "Oh,
Mm.
close." So they got closer and closer, and then someone got to Mars somehow because I guess I told them I was an engineer. And so they got really close. But the fact that I brought a rover, all of a sudden they're like, "Why do you have a space rover? Like, do you want to be an astronaut?" Like, they start asking me actual questions that they were interested in. And I was like, "Okay, this is good."
Yeah.
And so then we switched to a second activity, which is I called Mystery Box Part 2. And in this box, there are some things, I don't tell them what they are, and each team gets a box, and they have to use whatever tools they can find or whatever methods they want to guess what's in the box. So they can shake the box,
Ooh.
they can like tilt it in certain ways, they can use a stethoscope, they can weigh it. Like, what would you do, Claire, to figure out what's in this box?
I would shake it first so I can hear it.
Yep.
Uh, and so also I could sense how big it was when you shake it, you know?
Hmm.
That's what I would do first. I don't know what other things would give me more information besides being able to feel it. Can you feel it? Can
I
you
mean, you
like
feel the box, but you can't go
reach in the
inside the
box?
box.
Okay.
Yeah.
Yeah.
They could use magnets to
Oh, that's
figure out if it's,
creative.
yeah. But I mean, you're pretty limited. And
Yeah.
so the goal here is to, one, they hate the result, which is I can never tell them what's in the box. So they will
Wait.
never know. I know.
Can you tell me?
I don't know what's in the box.
What?
I didn't make the box. The other instructor made the box. And so she said there's something along the lines of like a rolling object, like a marble. There could also be like cotton ball, things that you don't hear as
Oh, there's
well.
more than one thing in the
There
box.
might be. There could be
Might
ramps in
be.
there.
I hate this activity for
Every
the
box is
record.
different.
Okay. This
I
is
know. So they're
horrible.
supposed to figure that out too by because a lot of students were like, "Wait, is their box the same?" And I was like, "I
Yeah.
don't know. Go find out." And they were so mad at me, and I was like, "I literally don't know. I don't know what's in the box." And they're like, "I'm gonna be up all night trying to figure out what's in this box. Can we figure it out?" And so part of the lesson is this idea of creativity that we unpack like, what had just happened? Oh, y'all shook it, but this team over here used magnets, but this team over here was a little bit different on the way they were shaking it, and they were like, tilt it this way and take notes. So the creativity
Hmm.
involved in this approach to figuring out what's in the box. Also, the fact that we don't know what's in the box. These are ideas that connect to the nature of science. You see where I'm going with this?
Yes, but I still hate that you don't know what's in the box.
I know. Well, in science, and this is the point I was trying to make, there is no answer in the back of the book, right? When
Yeah.
we are scientists, we're trying to uncover how this natural world operates so we can like
Mhm.
predict how things are going to happen. The fact that I can drop a ball and know that it's going to fall to the ground, right? But trying to like put that in a way where there's someone that's like, there is a force called gravity, right? If you look at the history of our understanding of falling objects, there are some wild theories on why objects fall and why they move and how they kind of, when you throw it up and why it comes back down, right? Because this gravity works. Like this explanation of falling objects has been proven over and over and over again. So we feel very confident that it is the way that this phenomenon can be understood.
Mhm.
So trying to get them to get that is like is a really interesting activity. I don't know how much they understood instead of just be frustrated with it, but what they resonated the most with is I compared what they did to this like poster of the scientific process and how we often think in science is like step by step by step, right? And it's like really boring. And we
Mhm.
talked about their experience in science, and they were like, I've just been told what to do. Pour this chemical into that, weigh this, write this piece of information down. What do you conclude?
Mhm.
And it's so dry and there's no creativity. And that is my favorite part of the activity is the fact that they're starting to understand that oh, it's on me. It's on me to figure out what's in the box. It's on me to ask you for a tool. I have to create a data table? Like, where would I start? So
Mm.
we
Okay.
actually, you see where I'm going?
I actually love it now. So
Good, I got you.
yeah, because it really is messy. And I mean, specifically thinking about space exploration, think of how much we don't know and how
Yeah,
engineers and scientists are having to figure out what tools you need to use. We've no idea. There's no like, "Oh, well, what was used before?" Well, I don't know, it's never been done before.
exactly.
I mean, I think yesterday we just discovered there's an asteroid between Mars and Jupiter that we'd never seen before. We had no tools to look for that. Nobody's over there to go check it. We can't, you know, listen to it or touch it or whatever like they do
So
in the box.
it's like direct and indirect observation is
Mhm.
another way you could approach this, and the fact that what we're doing is indirect, right? We don't know what's in
Mhm.
there. We can't physically touch it and observe it. So how do we do that? And the fact that I wasn't telling them what to do was such a shift for them. And we're in week
Mm.
4 now, and there's a few students that cannot get past the fact that I don't tell them what to do. And I told them day 1, I was
Mhm.
like, "We will do labs, and I won't tell you how to do them." And they're like, "What?" And they're like, "What is the answer?" Like, there's a student that's like, "What is the answer?" And I'm like, "There is no one answer. Like, I
Mhm.
just wanna know why you did that, how you got that result, and can you back it with evidence?" Like, that is what we're getting out of this class. And the transformation I've seen to some of these kids where they walked in bored out of their minds, I don't want to teach science, I don't care about this class, to like up and running around trying to be the first one to do this or like asking me questions is so cool. And it's not just the space piece of it. It's like the fact that I don't give them worksheets. I don't tell them how to do the labs. And so I'll walk you through a couple more in another podcast, but that was the start. Like this was start to our class on inquiry. And I think that word is key here.
Mhm.
It's the inquiry of physical science. It is not labs in the sense of I do this and then tell me what you conclude and then memorize this law. It is you go out and explore and start your own understanding of how this, material and physical
Mhm.
or material, natural world, that's the word, natural world works. So it's been a ride.
That is so awesome. I wish I could be in your class, and this just makes me even more passionate about what we're trying to do with STEM education in K-12 is because by the time these students have gotten to you and they're in their early 20s, it's this natural inquiry, this creativity has been beaten out of them.
Mhm.
And that's why I feel like most adults, you say, "Oh, science," and like, "I hate science." I'm like, "'Cause you haven't
You
really
do.
done it. You
Yeah.
don't actually know what that means." And so in STEM, I mean, I've had so many times that my students have experienced like what you said, where they're like, give me the instructions." And like, "No, like, I'm not telling you what
No.
to
Yeah.
build. Like, I gave you the constraints, but now you have to solve the problem and you have to figure out how to do it." They're like, "But I don't know how." It's like, "Yes, you do, but I'm not gonna tell you how to do it." And just overcoming that if they can just overcome that, that is success in STEM.
And I have a simple activity anybody can do that's listening. Whenever I was trying to explain what is science and how does scientific kind of thinking happen, I came up with this. I wasn't sure if it was gonna work. All I did was I put up a picture of something interesting. So I had the first picture was 2 monkeys fighting, right? Really random. And I was like, "Ask me a question. Like, what do you wanna know about this picture?" Right? And so they're like, "Why are they fighting?" Someone's like, "Are they fighting? Maybe they're playing. How do we know they're fighting? What's their name? Where did they come from?" Like, all these questions. Like, "Oh, okay, okay." So then I show another picture of a volcano erupting, and I'm like, "What do you wanna know? How hot is the lava? What happened to the lava? Did it hit, like, a town, right? What kinda damage did it cause? What causes the lava to erupt?" Right? So then I have the next picture, and it's of the moon. I'm like, "What do you wanna know?" And someone asked, "How much does the moon weigh? How do we even weigh the moon?" Here we go to the space side, right? And I'm like, "Oh boy, this is good." And so the beginning class, and this was right after the mystery box. So we had part 1 asking questions about what's in the box. Part 2 asking questions to design an experiment. And then part 3 are these pictures of what I later tell them are phenomenon. These are things that happen in nature that we're trying to understand, and that is science. You are asking questions that a scientist asks to understand the natural world. What do you think?
I love it, and I think that teachers should try this out and let us know how it goes in your own classrooms. So try it, email us. We would love to share your stories on maybe the next podcast episode about how your students responded to these types of open-ended questions to spur their creativity. That's awesome, Natasha. I can't wait to hear more about your students and
Oh,
what
I have
happens
more.
next. But for now, STEM space out.